Okay, so we are looking at sorting and filing data in this section. So let's look at raw data. So raw data is going to be data that is recorded in the sequence which it's collected. So it's just as I'm collecting. So like if I go around the room and I'm collecting pieces of information, it's just as I walked around the room. So it's not sorted or anything like that. So we say here, this raw data is going to be not sorted or grouped. Now, when I'm collecting those pieces of data, okay, so sometimes there's repeats in the data as I'm going through it, and that is going to be the frequency of that data. So the frequency is just how many times the data occurs. And then you have a relative frequency is going to be the ratio, not ration, so just cross that out there, of the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. So it's like we had in our previous class, we did on Monday, where we did this, where it went away, there it is, the number of dual enrollment students to the number of total students. That was a relative frequency. Okay, so there's actually a formula for that, which we had done before, but it looks like this. So you have F for frequency, and then you have sigma, so capital Greek letter S, sigma, that means sum of your frequencies. So that's your formula for the relative frequency. So this is going to be frequency of the category and then we're going to take that and we're going to divide that by the sum of the frequencies. Now, the cumulative frequency is just the accumulation of frequencies, so that would be adding the frequencies as I go. So I'm just going to write here, add as you go. A frequency distribution is a table of your frequency distribution. So it's going to list the categories and the classes and then the frequency of each. So if you just look down to 3.1 here, that's a frequency distribution, just this first part here. And then if we're doing the relative frequency of each category, then it's a relative frequency distribution. And you can see that you can have both in one table. So let's actually take a look at this table and we'll do our first frequency distribution. So our frequency distribution is going to record students' attitudes towards math. So let's go ahead and take a quick survey here. So how many of you could raise your hand and say that you love it? 1, 2. All right, I got 2. So my frequency, so you can do 2 like this, or you can do tally marks. So sometimes you'll see tally marks and sometimes you'll just see the numbers. Okay, how many of you would raise your hand and say you hate it? It's okay. 3. All right, 3 of you hate it. Good. All right, and then how many of you would say you're indifferent? So let me count this here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I got 14, 15 here. Okay, so 15, pretty indifferent there towards math. Okay, so we just did our first survey. Okay, now we can sit here and we can say the percentage of students in the class that have each attitude by using the frequency distribution. So you guys already know the math behind this. It's just now the wording of how it's done. Okay, so here, if I were to add all of these together, that's going to give me a nice even 20. And that's going to be my sum of my frequencies. Okay, it's 2 plus 3 plus 15. So my relative frequency is there are 2 out of 20 people who say that they love math. So there, let me get my calculator. we can do the relative frequency calculation, which would just be 2 divided by 20. Yeah, it should be 10%. And we're going to put that as a decimal. So 2 divided by 20 gives us 0.1. So I'm going to go here 0.1. So frequency is going to be given as a decimal. Now, in your homework, it will ask you to round to 3 decimal places unless it's like that. So if it were a running decimal, you would round to the 3rd place. Okay. Then you have, for hate it, you have 3 out of 20. So 3 divided by 20. Oops. 3 divided by 10. So 0.15 for our relative frequency there. And then indifferent, you had 15 out of 20. So we would do 15 divided by 20. And that should be, yeah, that should be 0.75. .75. So our frequencies are going to be the decimals. And then you can also go through and say the percentages there. So then we would just move these decimals 2 places to the right. So that 0.1 would give us 10%. The 0.15 would give us 15%. And the 0.75 would give us 75%. So we would say that is how our class, our sample, because we're just a sample, just one of the classes, feels towards math. Notice that if I do add both of these columns together, this is going to add up to 1. This is going to add up to 100%. Okay, that just means that I got all of my data. Excuse me. Okay, let's do another example where we're going to add in cumulative frequency. Okay, so now we have household size. So this is, think about how many people live in your house. People, not, don't include pets or anything. All right. So let's see here. How many of you have a household size of 1? Anybody live alone? No? Aw. What about 2? Household size of 2. 1, 2. All right, so I have 2 people. What about a household size of 3? 4, 5. Household size of 4? 1, 2, 3, 4, 5, 6. And then we're just going to go 5 or more. 5 or more. 2, 4, 5, 6, 7, 8. 8. Okay, so we have our frequencies for our sample, our class. And let's go ahead and add these together, see how many we got here. I think we got 21 here. 7. So we have an extra, either one person I didn't count in the last one or I counted someone twice here, but it's okay. Yeah, that's 21. So our sum of our frequencies, 21. So then we'll do the relative frequencies for each category. So for a household size of 1, it's 0 out of 21. So that would just be 0. Cumulative frequency, I'm just adding the columns as I go. So that's just 0. Next one, I have 2 out of 21. So here I would do 2 divided by 21. And that would give me, and we'll do 3 decimal places. So this would be 0.095 for that relative frequency. So 0.095. Then the cumulative frequency, you're just adding 0 plus 0.095. So that's 0.095. Yes, question.
For the decimals, you'll tell us decimals needed, or
It's, yeah, it'll say in the homework, round your answer to 3 decimal places. But I found, I think in pretty much all of it, it's 3 decimal places. Okay, household size of 3, you have 5 people. So this is going to be 5 out of 21. So 5 divided by 21. Three decimal places, 0.238. 0.238. Now for the cumulative frequency, what I'm doing here is I'm adding. So I'm going to do 0.95 plus 0.238. So 0.238 plus 0.095. So 0.333. Okay, so you're just adding the previous cumulative frequency plus the next line relative frequency for that. And you have 6 for household size of 4. So 6 out of 21. And that'll give us a 0.286. So there I'm going to add that. So 0.333 plus 0.286. Oops. I was trying to do the plus sign on my keyboard here. Plus 0.286. There we go. 0.619. Then you have 8 out of 21. So let's see here. A lot of people with big families. 0.381. And then we'll add that right here. So 0.619 plus 0.381, that should add to 1. Let's check that. And there you get 1. So it should add to 1 at the end of your cumulative frequency column. Sometimes it might add to 0.99 or 1.01, just if there's rounding, especially if there's like a 4 that you rounded a lot. So sometimes that might happen. But as long as it's within that, basically, usually within 0.02 tolerance. So like 0.98 to 1.02, you should be good. If you add them all together and you have like 1.31, you probably did something wrong. So go back through and check the math. So you can fill out that column and then you can answer questions about it. So question, how many households did we survey? 21. That's going to be the sum of our frequencies. So the total, just total pieces of data that I had here, 21 households. How many classes? We didn't really talk about what those classes were. Anybody want to take a guess? 5. Yeah. Well, I mean, you could argue 4 because there were none in the 1 category, but technically we did have that as a category. So we have 5 different classes. So that's just going to be the different categories right here. So that's going to be your X. Those are your classes. Yes, yes. So you're used to probably seeing them called categories. Now it's just a different like language vocab word for it. So classes. How many households had at least 3 or more members? So how many had 3 members? 5, right? How many had 4 members? How many had 5 members? So those all had 3 or more, right? So the 3 or more, you would take these frequencies here, add those together. So 5 plus 6 plus 8. And that should give you 19. And then how many had at most 2 members? Yeah, that's just this right here. At most 2 members, 2 households. So that's kind of a look at what you guys will be doing in that second part homework, filling out some of these tables, and then you answer questions about the tables. So this is when you have just single frequencies, okay, and relative frequencies. When we move on to the next chart, you're going to see something slightly different. This is the number of hours worked per week by a sample of students. Now, in this one, the number of hours has more than one category or, number in it. Okay, so what we do this, we're grouping it. So this is called a grouped frequency distribution here. Let me go back there. There we go. Grouped. Okay, and you can see very quickly when you're looking at these frequency distributions whether they're single frequency distributions or grouped, because the grouping ones have more than one number in those classes. Okay, so now this is hours worked. So the grouped frequency is going to have more than one number. So it's going to be a small, lower boundary, which we call our lower limit, to an upper limit in this distribution. So the lower limit here would be 0, the upper limit would be 9. Okay, so you're going to see more than one value in the classes. So let's go ahead and fill out this table. So we're talking about the number of hours worked. So raise your hand if you work between 0 and 9 hours. So 1, 2. I got 2 here. Okay. You didn't raise your hand? Okay, so just 1. Sorry, I thought you had your hand raised. All right, what about between 10, and this is not a day, this is a week, just to clarify. 10 and 19 hours. 1, 2, 3. Between 20 and 29 hours. 1, 2, 3, 4, 5. 5. Yes, I got you. Between 30 and 39 hours. 1, 2, 3, 4. I think 5. 5 again. Okay, and then between 40 and 49 hours. 1, 2, 3. Just 3. Is there anybody, some people work more than that out of the category? The first one? Okay, so 2. All right, if anybody work more than that, we're just not going to be included in here because we're just looking at it. Hopefully not. That's a lot. I'll have those weeks every once in a while. They're not fun. Okay, so let's go ahead. So we have our frequency distribution. Let's find the sum of our frequencies, and we'll fill out the table, and then we'll answer questions about it. So 2 plus 3 is 5, plus 5 is 10, plus 5 is 15, plus 3 is 8. Why am I getting different numbers here? Who did I not include? I got 21 people in here. All right, well, we'll go with 18 here for, it gives us, well, it gives us different denominators to work with, I guess. Okay, so you got 18 for your sum of your frequencies. Then you have relative frequencies. So we'll do 2 out of 18. That should be 1/9, so it's going to be a repeating decimal there. So it's going to be 0.111. And then percentage, it would be 11.1%. I'm just going to go ahead and round that to 11% for percentages. Then you have 3 out of 18, 10 to 19 hours. So 3 out of 18, we're going to get here 0.166 repeating, so 0.167. So if I move that 2 places over, that would be 16.7%. So I'm going to go ahead and round that up to 17%. Then we have 5 out of 18 for 20 to 29 hours. Yeah, 0.278. And then as a percentage, I would go ahead and round that to 28%. And then 30 to 39 hours is the same, so that's going to be a 0.278 again, and 28%. And then 40 to 49 is 3 out of 18, which we did in the 10 to 19 category. So we can copy that over as well. 0.167, so 17%. So we can take this data and answer questions about it. I'm just going to go ahead and add the percentages, make sure they add to 100. 101, close enough, we're good. Probably because of the rounding with the, yeah, because I had to round up 3 times, so that does make sense because I rounded up here, or 4 times, here, here, and here. So we're okay there. I could take this, I could put this into a circle graph if I wanted, or I could make a bar chart. So there's lots of things that you can do with the data and the displays. Here we're going to answer some questions about it. So we have here, what are the first lower limit and the first upper limit? So the lower limit and the upper limit are going to be these thresholds on the grouping. Okay, so the lower limit would be 0 here. And then the upper limit would be the 9 here. So for this first question, 0 for the lower limit, 9 for the upper limit. And then we can just, I can write it over here. So you have limit, okay, lowest number, and highest number in each class. Okay, then you have how many classes are there? So again, these are just the categories. So 1, 2, 3, 4, 5 different classes. Class width. So the class width sometimes can be confusing. So when you're doing the class width, there's a formula for it. So the class width, you're going to do the lower limit of class 1. So I'm going to go L, class 1, or class 2, sorry, minus the lower limit of class 1. Okay, which means I'm doing this, 10 minus 0. So the class width here is 10. All right, so the width is going to be the difference here. Okay, not 9 minus 0, 19 minus 10. So a lot of students will get that confused. So the width from the second category to the first category, the difference. Yes, or you could say the difference between the classes. So 10. So each one has a class width of 10. And then boundaries. So boundaries are going to be this. What if you get your paycheck and it's hourly and it says that you worked 19.4 hours and you wanted to answer this? Which class would you put yourself into? I put myself in the second class, but what if I work 19.5 hours? Then I go here. So the boundary is where you round, okay? So the boundaries are going to be that 0.5 in between each class. So you have a boundary at 9.5, at 19.5, 29.5, 39.5, and that's it. Or you could say 49.5. Yeah. Yeah, you could. So it's where would you round? You round at 0.5, so there's no trick there. It's just those are going to be the boundaries, the point at which you would round, which is 0.5 for whole numbers. But you're not going to get in an introductory stats class, you're not going to get anything that's not whole numbers when we're looking at these. So it's always going to be 0.5 here. All right, class midpoints, just like it sounds, is the middle of these guys. Okay, so you would take the lower limit plus the upper limit, divide by 2. So 0 plus 9 divided by 2 gives you 4.5. And then in between each of these, so then you got 14.5 in between 10 and 19. You have 24.5, 34.5, and 44.5. So we have how many adults work 20 or more hours per week? Yes. How many in this survey or in this sample? Yes, because we would do the 5 plus 5 plus 3 here. That would be 13. What percentage of adults work less than 20 hours per week? You have 5, or you could take these percents, right? Yeah, 11 plus 17, 28%. And then I didn't even notice right over here, we had these definitions. So the class width, lower limit of next class minus lower limit of current class is what I gave you guys here. Midpoint, upper limit plus lower limit divided by 2. Just put here 0 plus 9 divided by 2. And then your boundary. So boundary again, just think about where you would round. Okay. So we're going to do another example like this. Before I do that, does anybody have any questions about this example we did? Okay. So now what we have is we have data that gives, so it's already given to us and it's just raw data. It's not sorted or anything like that. So what we have to do is we have to sort this into a group distribution, and then we're going to, what are we going to do? We're going to make a dot plot with it. Okay. So this is the round trip commute times for all 30 employees at a company. So just notice that here right off the bat that it's telling me that this is all 30 employees. So this is a population. I'm not going to use that just yet, but it is important to start noting that. Okay, so complete the following table. Use 10 as the lower limit of the first class and use 10 as the width of each class. So remember the class width was the lower limits of each class right here. So that would be from 10 to 0, 10 to 20, 20 to 30, 30 to 40, like that. So if I'm using 10 as a class width and going backwards, then the next class would start at 20, 30, 40, 50, and 60. And then I could fill out the upper limits of each class because it would just be the number below that. So this would go to 19, then we'd have 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69. So now we're going to sort through our data and we're going to fill out our chart. So 10 to 19, let's look and see if we have any in that. I've got one right here at 12. And that's it. So I've got one in that first category. All right, 20 to 29. 1, 2, 2. And I'm crossing off as I go. That way it's easier for me to find the data as I go through each class. All right, 30 to 39. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. You guys all get 17? Okay, so 17 there, that's a lot. 40 to 49. 1, 2, 3, 4, 5, 6, 7, 8, 9. 50 to 59, I've got 0. And 60 to 69, I've got that one piece of data left, 1. All right, I have accounted for everything. I'm going to add these together. It should add up to 30 because it told me in the question there were 30 employees. So 1 plus 2, 3 plus 17, 20. Yeah, so this does add up to 30. So I can check. The sum is 30. So let's go ahead and do our graph here. So relative frequency. Let's see. So we have 1 out of 30. And that is going to give us, it should be 0.03. Let's 0.033. It is a repeating decimal, but we're going to round to 3 places. Cumulative frequency and then cumulative relative frequency. So the cumulative frequency is I'm adding this frequency column, so that's 1. And then relative frequency is this relative frequency column, so 0.033. All right, next one is 2 out of 30. We'll go ahead and do that. That's going to give us 0.066 repeating, so 0.067. The cumulative frequency is going to be 1 plus 2 for the frequencies. That would be 3. And then this, I'm going to add the relative frequency of 0.067. So that should be, I think that should just be 0.1. So yeah, 0.1 there. You could put 0.100 if you'd like. Not necessary. Then the next class, 30 to 39 minutes, you have 17 divided by 30. So let's see what that gives us. Good. 0.566, so we'll round that to 0.567. For the cumulative frequency, I would add the 17. So 3 plus 17 gives us 20. Okay, remember you're just adding the previous columns. This was 1 plus 2. Make that a little bit lighter. This is 1 plus 2. This is 3 plus 17. Okay, then here I'm adding the 0.567 to the 0.100. So that should be 0.667. Okay, then the 40 to 49 minutes, that's going to be 9 out of 30. So 9 divided by 30. 0.3. 0.3. Okay, so then here I would add 9 to the 20. So 20 plus 9, 29 for cumulative frequency. Then here I'm adding a 0.3, so that should be a 0.967. Then 0, that's just 0. The cumulative frequency doesn't change, so it's still 29 and still 0.967. And then 1 out of 30 is the same as I did in the first class, so that would be a 0.033. And then here I'm adding 1 to the 29, so that's 30. And then here I'm adding a 0.033, and that's going to give me 1. All right, and then you have a dot plot for the data. This one doesn't have the classes sorted out. So I could take this and just make this 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, and the 70 can just stay there. The dot plot really is almost like a bar graph. You're just doing the frequencies for each one, and instead of doing a bar, you're just doing the number of dots for each category. So here I would make this a really thicker dot. Let me see here. And then just make a dot for each category. So for in 10 to 19, I've got 1, so I just do a, oh, there we go, a dot there at 1, or at 10 to 19. And in 20 to 29, there's 2. And you kind of put them on top of each other like that. Then for the 17, I'm not gonna be able to put them on top of each other, but maybe go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, just however many dots. And then here there's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1 over here. No, they don't have to look exactly like that. Sometimes it'll be all the way up. Sometimes they'll be flatter. That is up to you. If you're doing a dot plot on your homework, it's really just picking out the correct one. Yes. Mm-hmm. I did add the relative frequency there. So yeah, I think in 3.2, I probably should have added just the frequencies because it said cumulative frequency and not cumulative relative frequency. So there, just add in that's relative. Because I'm so used to doing the relative frequency because that's usually what they ask for. They don't usually ask for both. So that's why. So yeah, if you guys want to insert that there for 3.2, that's really the relative, cumulative relative frequencies, not the cumulative frequencies. Any other questions? All right, let's take a look at sigma notation. So this is just notation for doing arithmetic, adding, subtracting, multiplying, dividing. But it's just a different way of writing it. So sigma is the Greek capital letter S, sigma, and in math, we've adopted it to use sum. So this sigma x here just means sum of x values. So you're going to do operations with those. It's just going to ask for these. You're always still following order of operations. So if it asks for multiplication, that would come before you do a sum because multiply comes before add. So here in example 4.1, you have consider the following data set of a single variable. Calculate. So sum of x just means add the values. So here this just means add your x values. So here we would just add these. So we would go 7 plus 39 plus 21 plus 16 plus 3 plus 43 plus 19. And that'll give us 148. Okay, now let's look at this. This is sum of x squared. So if we think about order of operations, and when I do order of operations, I like to use this, GEMS, instead of PEMDAS. Because this stands for grouping, exponent. This is multiply or divide left to right, subtract or add left to right. Because a lot of times in PEMDAS, people think that you have to multiply before you divide. Well, when you get to that MD and that AS, or add before you subtract, but technically it's as you get to it left to right, you do the operation. Okay, so that's why we use GEMS. But here, this says sum of x squared. So this is add x squared. So technically, what we need to do first is the exponent. So what this means is we're going to square the x's and then add. So square each x. Then add. So you could make a chart and you could square each of these. With our calculators, though, we do have this x squared button. So you could just put them in like that. So you could go 7 squared plus 39 squared plus 21 squared. So you can do them like that. 16 squared, 3 squared, 43 squared, and 19 squared. And then that should give you 4,486. Okay, but then in C, this is in parentheses. So that would actually come first. So you would do the sum of x first, then squared. So this is 148 squared, yeah. So add x, then squared. So 148 squared is, I don't have it written down. $21,904. All right, and then we have 4.2. So this is a bivariate data set. Does anybody know what that means? Just two values. Bi, okay, root word, that means two. So two values, an x value and a y value in the charts here. All right, so A says sum x, y. So if I look at my order of operations, I do multiply before I do a sum. So I want to do x times y, and then I'm going to add them together. So I can do this. I'm going to show you guys how to do this in your calculator shortly, but we are going to do it by hand first. So you have your x's and your y's, and I'm just going to rewrite them here. 4, 15, 0, 9, 12, and 8. And then the y's, 3, 5, 14, 7, 12, and 6. So then we could make another column for x, y. So we multiply these. So that would be 4 times 3, 12. 15 times 5, 75. 0 times 14, 0. 9 times 7, 63. 12 times 12, 144. 8 times 6, 48. Then the sum of xy is the sum of this column here. So sum of xy. We would add all of these together. You can do that by hand too if you'd like. You can add them. 12 plus 75 plus 63, 144, and 48. So 342. Okay, then x squared y, what do you suppose we do? We're going to square the x, right? Then multiply by y. Then we're going to add them all together. Okay, so we can do that. We'll do this one by hand, then I'll show you guys a calculator. So we would want to do x squared. So 4 squared, 16, 15 squared, 225, 0 squared, 0, 9 squared, 81, 12 squared, 144, 8 squared, 64. Then x squared times y. So then you're doing this column here, x squared, times y. So this is 16 times 3, so 48. Then 225 times 5, which I don't know off the top of my head. $1,125. Then 0 times 14, which is 0. Then 81 times 7. $567. 144 times 12. 1728. And then 64 times 6. 384. And then we add this column. So we'll go ahead and do that. So we have 48 plus 1125 plus 567 plus 1728 plus 384. So 3852. Okay, then if I go over to E, oh, I probably should. You do x squared, then y squared, then you multiply each of those, then you add them together. What this introduces, as we're doing it right now, is greater opportunity for human error. Okay, because it's easy to hit the wrong button on the calculator or to get a multiplication wrong because you're like, oh yeah, 5 squared is 25 or 36. You know, you just accidentally write the wrong thing. It happens. We all do it. So that's why we have the calculator. So this is why I was saying you really do want to get a calculator because you can do all of this stuff in there, which does reduce the percentage for human error. So let me show you guys how to do this. All right, so in your calculator, you have what we call lists. So you're going to want to do those. So if you look where, just 1, 2, so like the second row, third one over where it says stat, and then in orange or maybe yellow with different color on your calculator, you'll see where it says list. So that's what we're going to be using here. So I'm actually just going to hit the stat button and it's going to say edit. Okay, so where it says edit, I'm just going to go ahead and hit enter. And it should bring me to this column here. So I'm editing my lists here. Now, if you guys already have something in here, just go ahead and this little 4 function arrows here, go up and hit clear. Do not hit delete. You'll delete the entire list. So hit clear and then enter. And it should clear if you already have something there. All right, so this is L1. This is my first list. So I'm going to put my X's in this list. So I'm going to, okay, give me just 1 second. So you're going to go 4 and then enter. And then you're going to put the rest of them in. So 15, enter, 0, enter, 9, enter, 12, enter, 8, enter. Okay, so we have our X list entered. So now we want to go to our Y list. So I'm going to go over to the 4 arrows here and just go to the right into L2. And I'm going to put my Y list there. So I'm going to go 3, enter, 5, enter, 14, enter, 7, enter, 12, enter, 6, enter. So I have both my lists there. Now I want to do some operations with them. So let's just say I want to do the sum of x, y. So I just want to check my work for part A. So what I want to do is I want to go back to the home screen. So for that, you're going to go just second, and then right next to the second button is that quit button. That takes you back to the home screen. So second quit takes us back to the home screen. Okay, so now what I want to do is, let me see, I have to remember how to do this here. So give me a second. Nope. There it is. Okay. All right. So we're going to go to second list. And then you're going to go on your right arrow over to math. And I want the sum of x, y. So I'm going to scroll down to sum. So we did, again, so back from the home screen, second list, and then math, and then sum, enter. And I want the sum of x, y, which is L1 times L2. So you have two places where you can grab your list. You can either grab your list if you just hit the second list, and then it's just right here under names, enter. Or if you look down at 1, 2, 3, 4, 5, 6, it's got L1, L2, L3 there as your second operation. So I like to use those because they're quicker to get to. So L2, second L2. If I put it in just like that, L1, L2, sum L1, L2, it's going to multiply them for me. And I get the 342. Okay, so you do your operations like that. So let's go ahead and check these. So we'll do C as well, just to show you guys that. So you go second, list, math, sum. Now this sum, I'm doing x squared y. So that's going to be L1 squared. So second 1 for L1 squared, and then second 2 for my y for L2. You can put a times in between there if you'd like. You don't even need to put that parentheses at the back. I just like to do that. And it gives me that 3852. Okay, so let's go ahead and try these. Why don't you guys try them, and I'll show you the answers in just a second. Try doing the rest of these 4. And I'll walk around and help if you need help. Okay, so real quick for these, for E, you would do the sum, so second list, math, sum, and then I would want L1 squared, and then L2 squared. So that should be 32,778. Then this is sum of yx. That should be 342 also, because x times y times x. Same thing, commutative property there. This is the sum of xy squared. So this is actually the sum of xy, so 342 squared. You can just do that. So that should be 116,964. And then for F, you would want sum of L2 squared L1. So second list math, sum, and then you want L2, so second 2 squared, then second 1 for L1. So 2868. So I'll write those down for you guys. So this is 32,778. This is 342. This is 116,964. And then this was 2868.